Now we're going to start some operations with vectors, just using the component form and putting the numbers together. This will be pretty straightforward. It will be really just adding, subtracting, multiplying, distributing, that kind of thing. But we start with example 2. We'll do both these examples in this video. Where example 2, u plus w, that is just taking the values from each of those, taking the x's, putting them together, taking the y's, putting them together. And so this really just means 2 plus 1 for the x's from each vector, and then 5 plus 4 to give us a component form of 3, 9. So pretty straightforward as far as that goes. With this next one here, we do want to make sure that we're distributing the number that's being multiplied first before we add them together. So this is like saying here we've got 4 times the vector 2, 5, that's u, plus 2 times w, which is in component form the vector 1, 4. So then we can distribute, and we get then 8, 20 plus 2, 8. Add those together, and we get 10, 28 for our vector. All right, so that's if they're already in component form, the u and the w, as you see up on top there. Now let's take a look at example 3, where the information that we're given to start with is actually just single points, as you can see there. When we make a vector like this, if it's PQ directed from a couple of single points, the way we're going to do this is terminal minus initial. Now the terminal point is always the one that's listed second. So in this case, we're going to go Q minus P for these different components. So what that means here for Q minus P, we've got Q, we've got P. We're going to start with the x's and do -1 minus 2 in this spot. That's going to be our x-coordinate, and then our y-coordinate is going to be 3 minus 4, because again, that is terminal minus initial, Q is being the terminal in this case. So that overall gives us -3, -1. Now the other question being asked of us in this example is to find the magnitude of the vector. And so the magnitude of the vector, what we can do is, again, like what I said before, these absolute value bars are what we're going to use to indicate magnitude. And so that is just going to be that square root formula where you go x squared plus y squared. And so we have here square root of 9 plus 1, so really square root of 10, and we're just going to leave it at that as far as the simplified form of that magnitude. Once you get into this next one, though, just a thing about this one, it's a little more complicated. I'm going to quickly run through the whole thing, but remember that we have to multiply before we add together. Now QS, we're going to again do terminal minus initial, so S minus Q in this case, and that's going to look like this. It's going to be 1 minus -1 for the X, and then -7 minus 3 for the Y. I would encourage you to pause the video if you're trying to track through all these things. And then the second part of this is going to be PR, so it's going to be R minus P, and in this case we are looking at 3 minus 2 for the X's and -4 minus 4 for the Y's. Now we just go through and simplify things one at a time. So this will be 2 times the vector 2, -10, and then we have the vector 1, -8. Distribute, do the multiplying before you add those together, and so that'll give us 4, -20 plus 1, -8. And then finally here we can add those together to get the vector 5, -28. The magnitude again is found by that pretty much that same formula that we did before, not pretty much exactly the same formula. And so the numbers will be a little greater in this one. We're going to have the square root of 5 squared plus -28 squared, and then you can simplify that from there. I think you can take that one the rest of the way.